So, good morning, everyone. My name is Thiago, and today I'm going to present Go for Rubyists. Okay, let's start telling a little bit about me. My name is Thiago Pradi. I'm Brazilian. I do have this bizarre accent, so I'm also a software developer at JobScore, which is a company based in San Francisco that has some offices in Brazil. I'm also Bachelor of Computer Science from FURB, and I'm Octopus author and maintainer, which is a database shard implementation for Active Record. But today I'm going to talk about a different topic here. Okay, let me start by telling a story here. This story is about a happy Ruby developer. Okay, Thiago was a happy Ruby developer, but yeah. Oh, sorry. This is a picture of me being a happy Ruby developer. It's kind of old, you can see by the bizarre computer. Yeah, that's wanted to learn something new. Yeah, why not learn something new? Maybe a new programming language would make me a better program. Maybe I should try Go. That sounds like a good language. But, I mean, let me check the trends about Go. Oh, they're growing, a lot of people are talking about it. It's like Google are behind the language, so it's growing faster. And what is Go? I mean, what is the programming language? Go is a programming language that was initially developed at Google. The guys at Google are trying to create something to solve their problems. It was created by Ken Thompson from Unix, Rob Pike from Play9, and Russ Cox from libtask, which are great guys. The development starts in 2007, and the first release was in 2009, which means the language is fairly new, if you compare it to something like Ruby that has like 20 years of road. According to golang.org, Go is an open source programming environment that makes it easy to build simple, reliable, and efficient software. Okay, that sounds like a great description. Let's jump in. The features of the language. The language is new. The guys at Google are trying to create something new from scratch. It's also concurrency. There are some constructions to make it easy to build concurrent programs on the language. It's compiled, different from Ruby, that is a scripted language. It's a compiled language. It's also garbage collected, which is good. You don't need to free your memory. And it's simple and fun. Okay, let's check it out. The focus of the language was to do like system programming. The guys at Google are having like big troubles doing system programming. Inside Google, the infrastructure is like huge and massive, so they need a tool to solve the problems inside Google. It also needs to deal in a good way with network and multi-core. I mean, you need to write your program for 2 cores and then run like in 4 or even 8 cores. It also needs to be fast. No one wants like to be waiting for a program to compile and run. It needs to be compatible with C. Like, so guys that already know C, it's easy to switch to Go. And they are trying to pick the best from both static typed language and dynamic languages. So they're trying to combine to create a new programming language. Okay, a few basic concepts about the language. Here is the hello world. This is a hello world in Go. I start by saying the package is main. Import the format function, which deals with format in Go, output, and that kind of stuff. I create a new function named main, which call fmt.println hello world. Okay, cool. This is our first hello world in Go. As you guys can see, Go has a C-like syntax, which means it inherits a lot of stuff from C. Like, this is the printf function. It's similar to C. That makes it easy to switch programmers from C to Go. That was one of the goals from the guys at Google. Okay, Go is also a compiled language, like I said. I have to type go build hello.go. It's going to generate a new executable named Go. When I execute it, hello, okay, hello world is printed on the screen. Pretty cool, huh? Also about the type system, Go is strongly typed. This should be a picture of me doing something like this, but yeah, better not. Go has strong types like Ruby. If you try to do operation in two variables that have different types, the compiler is going to raise error, say, hey buddy, you're trying to concat a string into an integer, in this case. and it's going to say, hey, these types don't match, like it's mismatched. So like Ruby, the compiler does some checks and see if the variables like match. But Go is a static type that's different from Ruby. You have to declare every variable before you start using it, and you have to say the type of the variable. In this case, I have the variable A as a string, and I try to assign an integer value. When I compile the program, the compiler is going to say, hey, buddy, you cannot assign an integer into a string. You need to declare it as an integer. This may sound like boring, because you have to declare every variable before you start coding. So the guys created syntax sugar, which means that you can use the special syntax. It's comma equals to say, hey, compiler, you should know the type for me. I don't need to specify the type here. Like in this case, I have the variable A, which assign the value 1, 2, 3, and I print it. I use the printf function to print the variable. Okay, when I run it, value of A 1, 2, 3. Pretty cool, huh? Also, you can define your own user types. This is similar to what you guys have in C. I start by declaring a new type and an animal, which is a struct. There's the attribute name as a string. There's the attribute age as an int. If I want to use this struct inside my program, I just declare it's like var anaconda as an animal. Anaconda is a crap movie from Brazilian snakes. We don't have that kind of snakes. Yeah, you guys should watch it. It's fun. The compiler of Go, it uses GCC as the backend, and it checks for UNIZ package and variable. Like if you have a UNIZ package import inside your program, it's going to say, hey, buddy, you have a UNIZ package here. Why you don't remove then? It's going to raise an error and you need to remove before you continue with your program. The same applies to variable. And since Go is static type, it checks for type and return values to see if they match. There are some Go tools. This is one of the best parts of the language. There is the Go format, which formats your source code for you. This is pretty cool. You have a source code that is not indented. It's like all messed up. You just type Go format and pass the name of the file. It's going to format the file for you. And you don't need to worry about, hey, how should I format this? Or what kind of indentation should I use? Just type Go format, the source code, and you are good. There's the Go get, which manage and install your dependencies. There's the Go build and run, which like compiles and run your program. There's the Go test, which runs your tests. To organize code in Go, we have packages. Every source file needs to have a package declaration. In this case, I have my package named string processing, which has a function process. In Go, if I declare a function that starts with a capitalized letter, it means that this function is going to be public. Otherwise, it's going to be private. This is one of the conventions of the language. We don't have like the public and private declaration. Just start with a capitalized letter, and it's going to be public. To use this package inside my main program, I import string processing, and then call string processing.process and pass a string. The workspace is the default way to organize code in Go. It was built to work with open source repositories. There is the directory source, bin, and package. This is like similar to Java, but in a different way. Like this is my workspace. I have my bin, my package, and my source directory. Inside the source directory is the github.com, change, and mail, which is my project. If I start typing go build github.com/changes/mail, it's going to compile. And since I have two different packages inside this project, the command parser and the main, it's going to generate a new library inside the package directory, named command parse.a, and generates the binary inside the bin, which executes the program. Encoding, source code in Go is UTF-8 and strings are UTF-8. Thanks God. Okay, compare it to Ruby. First of all, I want to do a disclaimer. I'm not here to show like what language is best, like Ruby is best for this, or even Go is best for this. I just want to make sure you guys are learning something new by something that you already know. Like it's easier to learn something new based on things that we already know. Okay, object orientation. Ruby uses class and methods, and Golang uses interfaces adding methods to data structure. This is a bit different to what we are using in Ruby. Objects in Ruby, there is the Ruby object model, which like kind of controls all the object orientation inside Ruby. There is module and class with methods. There's support for inheritance and composition, and everything in Ruby is an object, as you guys know. Here there is the class named animal, there's assessor name, initialized by setting the name, and there's the method say something. In the program, I just start animal.new and pass the string named duck and call a.say something. Objects in Go, there aren't no inheritance. Data types define the contents and methods define the operations. So interface defines the behavior of the object. Okay, here I have my type animal, which is a struct, has the attribute name as a string. There is I use the special syntax to add methods into the data types, which pass function and pass animal, say something, which creates the method inside this data structure. And here my main function starts by instantiating a new object. The new command here does the same thing as Ruby, it allocates and manages the memory. And I set the name as a duck and call the method a.saveSomething. Error handling. In Ruby, we use exceptions with begin, rescue, and ensure. In Golang, we use return values with error codes. Okay, this is weird. All the errors in Ruby inherited from exception class. We do flow control with begin, rescue, and ensure. You don't need to treat every exception. Like if your method raises exceptions, the program will blow up. There is no need to treat every exception by the compiler. So I start by opening this file here, name it tmp.mel, and I start with a begin block and do some file processing inside this begin block. There is the rescue here in case exception is raised. So I print it out, failure to process, and there is ensure that make sure that in the end of the processing is going to close the file. I mean, if something bad happened, if your program blow up inside this processing, it's going to make sure that your file will be closed in the end of this block. In Go, we don't have exceptions. Error should implement the error interface. Error should be returned as additional value to the return of the function. And every error should be treated unless you want to do a gambiarra. Okay, this is off topic, this is a gambiarra. This is one of the best words in Portuguese. If you saw some Brazilian programs here, you should say, hey, you're doing some gambiarras here. He's going to be really mad with you. Okay, I start my TCP server here, which returns me a listener and an error. And since I have to use every variable inside the program, I have to check if this error is different from new. Print it out, the error starting server, and I call os.exit1. This is similar to C that don't have exceptions, but since we have multiple returns value in Go, we use this syntax. Also, there is the defer, panic, and recover. Defer is compared to ensure in Ruby. Panic and recover are similar to exceptions, but they only should be used for internal APIs, like to raise array out of bounds errors. And panic is used for runtime errors, like I said. Okay, here I have my function named echo connection, which receives a connection and a server storage. I call defer connection.close. This defer call is going to put on the heap this call to close, and it's going to execute the entire function. When the function ends, it's go back and say, hey, I have the defer function, and the file will be closed here. Okay, there is also an example of a panic. There's the panic function, which has a defer block, and inside this block I printed out call a defer function, and after there is the panic function with this robot voice. When I call this function on the main program, it's going to execute, and then it's going to read the defer function, okay? It's going to call the panic, and it's going to blow up your program. But before it blows up, it's going to call what inside this block. This block makes sure that it is executed, like even if a panic is raised inside the function. To recover from panic, we have this recover function. This is kind of the same method as the previous slide, but there is a call to recover inside the defer. And when I call the panic function, it's going to panic, blow up your program. And it's going to read what is inside the defer function. Hey, there's a recover here. I mean, this function will finish. It's not going to print that last line, But your program is going to continue to run. So yeah, it's kind of the same if we have with rescue in Ruby, but this should be only used for internal things, never for your program. Your program never should return an error in this way. Okay, concurrency. This is one of the best parts of Go. Ruby, you have threads, fibers, event pool, we have actors. In Go, we have Go routines. So, concurrency Ruby, like I said, we have threads with shared memory. There is fibers, there's also event machine, which is event loop and reactor pattern. There is Celluloid, which is a new and cool project that does actor-based concurrency in Ruby. Okay, here's a small example of some Ruby code. There is I start by creating a new thread and calling do a get inside the specific URL. So, and I put this content inside array and wait until the threads finish it. In Go, we have Go routines, yay. You can think as Go routines are lightweight thread implementations. And they communicate between Go routines, we use channel, we do not share memory. And all the Go routines are managed by the Go scheduler, which is good. You don't have to worry, hey, about, this Go routine needs to run on this car, or this Go routine needs to run on this car. The Go scheduler can do it for you. And you can even specify how many cars you want to use your program. Hey, I want to use 2, or I want to use 4, or I want to use all the cars from the server. Like I said, the Go routines are mapped to a few different OS processes, like it's a N versus N mapping. Okay, here I have my listener which accepts a connection and returns me a connection and a error. I treat the error here and call the echo function passing the connection in the server storage. Okay, to make it a Go routine is easy like that. You just put the Go call before your function call, and hey, you are running on different Go routine. Cool. To communicate between Go routine, I have channels. This program creates a new channel, which receives a string. It calls the ping function as a new Go routine and passing the channel as a parameter. So it's going to read the next line and say, hey, we should wait this main Go routine until there is some message in the other Go routine, in the other channel. And the ping function is going to be called and going to put a message inside that channel. And when the main Go routine look and say, hey, there is a message here, I should continue. And then it's going to print it out, that message. This is the way you communicate between Go routines in Go. I have also an example of it. I wrote a download manager in Go. So I download the file in different chunks, and all the chunks are running a different Go routine. I start here by creating a new channel from the type channel result with the number of connections that I want. Like I want to download a file with 10 connections. I call here the Go make request, which passes address, a start byte and an end byte, the output and the channels. And I do the loop here, waiting until there is some message inside this channel. When there's some message, I do pick up the message and then save the file. This is cool. I do get concurrency without worrying about sharing memory and that kind of stuff. Mutex and all this bizarre stuff. This is one of my open source projects. If you guys want to check it out, it's on GitHub. Okay, testing. Ruby has a built-in framework, which is test unit and a lot of alternatives. And Go also has a default framework for testing and some early stage alternatives. Okay, let's check it out. Testing in Ruby, there are a lot of frameworks like test unit, RSpec, Minitest, and even Bacon. Bacon is a nice name for a testing framework. The frameworks come with a lot of assertions and predefined macros. Like you have a lot of syntax sugar inside your testing. It was easy to describe behavior, to do BDD, and everyone tests here, right? Everyone tests here. Everyone should be testing. Okay, here's an example of one of my open source projects. I described the Octopus model class using the describe, describing the method using, and the method should return self and do the check, hey, user.using Canada should be Octopus proxy. It should return self. Okay, testing Go. There are some light frameworks with the language, with a few new options. The guy from Pivotal Labs are trying to create a different framework, but the most famous is the framework that comes with the language. It doesn't come with sessions and macros. The tests have the same package as the application code and also stays the same directory as your application code. This is different from Ruby that we have separated the directories to store your tests and your application code. Okay, here's an example of a test. I import the testing package. I have the same package as the main program, which is the command parser. To be a test, I need to start with the test underline word, and there is the method named parse set command, which receives a test. And I start by creating a new server storage object, calling the parse command on the object, and in the end I check if the word in the dictionary is different from valor. Okay, the test failed. This is kind of the same thing that we have like with assert equals or even equals on our spec, but without the syntax sugar. The guys at Go are trying to create something lightweight, so no syntax sugar for the testing framework. Okay, but what about some real use cases? There are some companies using it. Google, of course. They are using on dl.google.com and also on YouTube. There's SoundCloud, which the guys at SoundCloud are here. Heroku is also using Cloudflare and Ubuntu. There are some open source projects. This is really cool. It's a process into the first one. It's written by the guys at YouTube. It's a processing tool for scaling MySQL, like to scale down, scale up. They have bigger problems, so they write this tool in Go. There is the open source application container engine, which is Docker. They migrate from Python to Go. And there is this use, which is a Rails preloader. It's a nice project to start looking out to see how Go code looks like. Mine, I haven't wrote some Go code in production, but I have some open source projects. There is the yet another download manager, which is my download manager. There's also a brainfuck compiler. Everyone should write a brainfuck compiler on a new language. There's also my key value database. Please don't use it on production. It's not ready. Wrapping up, Go is a cool language. It's concurrent and networked. It has the benefits from both dynamic and static type language. It's modern, and I think you guys should give it a try to be a better program. Oh, there is one more thing. I hope I made a real nice Go with this Golang talk. Oh, this is the Argentinian version here. A real nice Go. Okay, thank you guys.